Hello, and welcome back to Vector's All Things PC-lint Plus YouTube series. I'm Jacob Cole-Petro, a field applications engineer at Vector. This will be part one of the series where we'll be covering the compiler configuration setup for PC-lint Plus utilizing the pclp_config.py Python script. Alrighty, so before we get started with the demonstration for today's video, I just wanted to discuss the setup for PC-lint Plus a little bit. There are two main requirements that you need in order to get PC-lint Plus working. The first is the compiler configuration, which we'll be going over today. The second is the name or a list of source files. Once you have those two things, you can run a basic analysis on the source files provided. So it would look like call PC-lint, pass the compiler configuration and the source files to it, and it'll run the analysis and give you any findings it may discover. So you can additionally add an options indirect file to house any other options you may have, such as suppressions or different coding standards. But as a general rule, this isn't actually required for PC-lint to work. It's just there to provide additional options. So this begs the question, how do we get this compiler configuration that's necessary for PC-lint to work? Well, the method I'm going to show you today to generate the compiler configuration is by utilizing the pclp_config.py script. And this can be found within the config directory of your PC-lint install, as you can see here. So this method's actually very quick and very easy and can give you a working compiler configuration in only a couple minutes. So now we're going to move on to how you can actually use this script. So I moved over to VS Code and I've created a batch script here called runlint.bat. And this is where I'm going to be doing most of my work throughout this series. I am using a batch script on Windows. However, everything that I do throughout this series can be replicated on Linux if that's your preferred platform. So you can see on lines 1, 2, and 3 here that I've taken the liberty of setting up some environment variables. The first on line 1 is pclp_dir, and that just points to the directory where my PC-lint executable is located, and that's here. Next on line 2 is pclp_config, and that just points to the config directory. So if we go back in here, I have this config directory, and this is where our pclp_config.py script is actually located, which we're going to be using to generate the compiler configuration. The last environment variable on line 3 is source-based-dir, and this is just a base directory that I'll be using to find my sources. So my C and C++ files. Okay, so we have our environment variables on line 1, 2, and 3. All we have to do now is call the script with a few options in order to generate the files we need. So the first thing to do is call the script, which I've done here on line 6 already. And just as a note, you will need 2 Python modules in order to get this script to work. They are regex and pyyaml. So if you don't have those installed using a pip install, then go and do that, or else you'll run into some errors with this script. So the first option that we're going to need is --compiler equals. And I said previously that I'm going to be using a GCC compiler throughout this series. So this option is just used to specify the compiler family from the list of supported compiler families that PC-lint can use. So in my case, I'll just have to do GCC. But say in your case, you're using IAR, you would do the specific IAR compiler family here that you're using. And if you're curious about what compilers are supported for PC-lint, you can just call this script with the option --list-compilers, and then run the script, and it'll output a list of supported compiler families that you can choose from. So just getting rid of that option. The next option we need to provide is --compiler-bin equals. And this option is going to be used to specify the full path to your compiler binary. So in my case, that's located at c/min-gw /13.3.0/min-gw 64/bin/gcc. So this is the actual binary for my GCC compiler. In your case, you would do the same. If the compiler is on your path, you just need to provide the name of the binary. You don't need the full path. But I just wanted to give the full path in this case since, just to demonstrate. The next option we're going to be using is --config -output -lnt-file equals. And this option is used just to specify the name of the output indirect file. This is going to be the actual file that the compiler configuration is. So this is where those type sizes, those standard libraries are going to be located. So just provided a name. They're generally prepended with a co dash, so we'll do that here. So co-gcc.lnt. The next option is for another file that kind of goes hand in hand with this indirect file. It's going to be --config -output -header -file equals. And as I said, this option is used to tell PC-lint what the name of the compiler configuration header file will be. So this is just another file that's going to be generated, and it's going to be automatically included in the compiler.lnt file. And it just contains a bit more information, like some more built-in macros for the compiler. So again, just going to give it that co-gcc.h name. So the last option that we need to include before we can run the script is to end the call with a --generate -compiler -config. And this just tells the script that we want to generate a compiler configuration. And once we add this, we can save our changes and run the script. So we'll just do a run lint, hit tab.bat. And we've generated the two files. You can see they populate over here. So I'm just going to dive into those to see what we have. You can see here that header file is automatically included. And then these --i and plus libdir options are where all of our standard library headers are located. And if we scroll down, you'll see there's just more compiler options here. Some -ds and just some other size options down here and other macros. And if we go into the header, you'll also see just a bunch more macros that the compiler is using. So now that we have these files, we can do a very simple PC-lint Plus analysis on a single source file. So to actually run the analysis, I'll just need to invoke the PCLP64 executable that I'm doing here on line 9. And this is just located in our PCLP dir, the environment variable that we set up on line 1, and you can see that here. That's where our executable is. And so we'll just need to pass to it that co-gcc.lnt that we just generated. This is our actual compiler configuration. As I said earlier, the co-gcc.h file is automatically included in this, so we no need to add it here. And the last thing that you'll see on this line is just a source file, just the name of a C++ source file that I'm using my source base directory to point to. So all we need to do is run the script again. Okay, now that's run. You can see that we're actually running PC-lint Plus as it says here, and we have some PC-lint Plus findings below that. But I want to clue you in on this last PC-lint Plus finding. It looks like PC-lint can't find one of our include files called export.hpp that's included for the source file. So what can we do to remedy this issue? Well, we would need to find my project or my code base's compiler settings for each source file in order to get the include paths for this error. But that's a problem for the next video, so be sure to tune into that next part where we'll go over how you can automatically pull the compiler settings from your project, such as the -i's and the -d's for PC-lint to use. So to summarize, today we went over how to automatically generate your compiler configuration for PC-lint Plus to use just by utilizing the pclp_config.py script, which you can find in the config directory of your PC-lint install. I want to remind you again to please check out the next part of our series where we will go over how to pull your project's compiler settings directly from your build system very easily for PC-lint Plus to use. I want to thank you again for watching and have a good one.